An electric vehicle caused an explosion that ripped through Faraday Future's headquarters in Los Angeles, California. It actually made their building structurally unsound. But what makes this incident so unusual is how little fire was actually involved. You found stashed. I'm Pat, firefighter, mechanical engineer, and battery guy. According to the Faraday Future's official statement, this was a minor fire involving a prototype vehicle. They said there's no evidence that the high voltage battery pack was involved and that operations would continue as normal. But that's really unlikely. After gathering data and looking at the fire report, I really believe the high voltage battery was involved. The crazy part was, the vehicle that failed wasn't even charging. It wasn't even a test. In fact, it had been sitting in the showroom, untouched, for over a year. Unfortunately, we don't have a lot of information on the state of charge of that vehicle, but based on the fire damage, I suspect it was relatively low. But I'll come back to that. At around 2 a.m. on September 28, 2025, the Los Angeles Fire Department was dispatched for a reported structure fire at Faraday Future's headquarters. When they arrived, they found heavy, cold smoke pouring from the Alpha side of the building.
All we see is heavy smoke on Alpha side here. Yeah, copy that. Heavy smoke on Alpha.
That's the front, facing the main entrance. Basically, it was a lingering smoke that was whitish gray in color, a telltale sign that a large lithium-ion battery was failing. Believe it or not, there's actually an art of reading smoke. Actually, there's a whole series of classes around the topic. But firefighters can tell a lot about what is burning in the structure just by the color of smoke, velocity, or volume. Command did a 360 and immediately noticed something didn't add up.
Figueroa Alpha, be advised on the Bravo side you have structural compromise. This is a possible explosion. You do have heavy smoke coming from what looks to be structural damage on that Bravo side.
Inside, they found a single vehicle, a Faraday Future's prototype. It was sitting in the middle of a showroom, burned but still recognizable.
Updated information is I have an auto that was well involved inside. Appears to be knocked down. I do have structural integrity loss on the Charlie wall. We're going to be investigating a little bit further, but I'm thinking about pulling back here in a moment.
Crews initially backed out of the building and they called in hazmat. Thankfully, hazmat was able to arrive fairly quickly and they began monitoring air quality inside the building. Their readings told a very real story. Hydrogen levels were elevated, and those sensors are not affected by carbon monoxide. Typically, firefighters carry meters that are cross-sensitive between carbon monoxide and hydrogen. So basically, we confirmed there was a hydrogen release. Carbon monoxide levels were also high, along with hydrogen cyanide. And while they picked up what looked to be phosphine gas, crews later determined it was likely cross-sensitivity between phosphine and hydrogen cyanide, which makes a lot of sense chemically. We'd certainly expect a high level of carbon monoxide and hydrogen cyanide in any structure, especially when plastics are burning. But high levels of hydrogen and carbon monoxide are exactly what you'd expect from lithium-ion batteries and thermal runaway. And that hydrogen buildup is likely what caused this explosion. What's really interesting is that these gas readings stayed elevated for more than an hour after the fire was actually out, meaning the batteries were still venting internally, and in this case, the gases were building up inside the building, which wasn't fully ventilated after the initial explosion. That's a situation that does put firefighters at a real risk. When the smoke cleared, firefighters realized that the vehicle was the only thing that had burned in that structure, and the structure itself showed almost no fire damage. LA Building and Safety later red tagged the structure, meaning it was unsafe to enter. And the vehicle had to stay exactly where it was at until they could remove the doors and glass walls so they could safely remove it from the structure. Faraday's public statement downplays this event, which is expected. They say there was no indication of the battery's involvement and suggested it could have been a building's electrical issue, but looking at these pictures, it's pretty obvious that the vehicle was involved, especially when you look at the gas data recorded on scene. This was a high-voltage battery event that released an enormous amount of flammable gas, but very little heat. The vapor cloud explosion was short and violent, and there really wasn't any sustained combustion of the vehicle itself. This is an area where I've had some concern for quite some time. Whether it's a dealership showroom or an auto show, there are strict rules for this and for good reason. If it's a gasoline or diesel vehicle, the fire code says the tank can't be more than 1/4 full, or 5 gallons max, whichever is less. The fuel cap has to be sealed, the battery has to be disconnected so nobody can accidentally power anything up, and you have to have a fire extinguisher nearby. It's pretty simple. Isolate the ignition sources, control the fuel, and make sure the vehicle can't start. But when it comes to electric vehicles, the code isn't nearly as clear, and that's where things get messy. When you're indoors, you're not supposed to charge the vehicle, but the high voltage battery still sits, storing a lot of energy, often at 80 to 100% state of charge. On top of that, we don't really want to disconnect the 12-volt battery, the low voltage battery, because it's powering important things like the battery management system or the thermal management system. Now, there are some manufacturers that recommend having that vehicle in the showroom at a low state of charge, somewhere around 30%, but there's no consistent standard for dealerships to follow. Unfortunately, at a lower state of charge, you're typically going to see off-gassing as a failure mode, and that could lead to an explosion. At a higher state of charge, you're likely to get fire. It's a perfect example of why you can't always judge a fire by how much it burns. In fact, the less it burns, the more dangerous it can be. So, what could have caused this? The truth is, we may never know. A post-mortem on that battery would be a great place to start, but the damage might be so extensive that it's difficult to learn much from it. This explosion wasn't about charging, misuse, or even a design flaw, at least that we can point to. It's the fact that energy doesn't just disappear. It sits there, waiting, and as these vehicles age, the chemistry inside, it just keeps changing. It's a reminder that even with everything we've learned about lithium-ion batteries, we still don't fully understand what happens when they fail quietly.